All right, this week we're going to begin to talk about ratios, rates, proportions, and a lot of these things can be easily confused with fractions. So I wanted to start by reviewing what a fraction is. A fraction is either describing part of a whole, and it's going to be less than 1, usually, if the part is a smaller number than the denominator, the whole. Uh, Fractions can also be improper fractions, and we know that that can be larger than 1. When we simplify it, we'll get a mixed number. But for the most part, fractions are smaller than 1 whole because you're comparing part to the whole. We could also use fractions to describe part of a set. So I've got two examples here. This first one over here is, let's just say it's a pizza, and part of it is shaded in and part of it is not. So if we were to describe the part that was shaded in, we would count the number of pieces that are shaded, and that would be 2 pieces. And then we would count the total number of pieces there are, and that would be 4 pieces. So 2/4 does describe this particular picture. But as we have reviewed earlier this year, this is not the simplest form of this particular fraction. So what number could we divide the top and the bottom by? Go ahead and answer that for me. All right, so to actually find an equivalent fraction that is smaller, we're going to divide the top and the bottom by 2. So if you said 2, you are right. So if we divide 2 by 2, we get 1. And if we divide 4 by 2, we get 2. So the simplest form will be of this fraction here will be 1/2. And I'm going to actually move this around a little bit. And if I were to take that piece and put it over here, you can easily see that that is true. 1 out of 2 pieces is shaded. So this is an equivalent fraction to the fraction 2/4. Now, fractions can also be parts of a set. So let's say this is just a big old group of puppies, and you're looking at the puppies, they're all over the place. 2 of those puppies have spots, the rest of the puppies do not have spots. So the set will be all of the puppies. So this right here would be the entire set all over the place. But you can describe that there are 6 total puppies. So you count the puppies, there are 6 puppies. And then 2 of those puppies, part of the puppies have spots. And so the fraction that's going to represent this set is 2 out of 6 puppies have spots. But as we also recognize here, the top and the bottom have common factors. So we can simplify this. What would we divide the top and the bottom by? Go ahead and answer that question. All right, so once again, we're going to divide the top and the bottom by 2 because these are both even numbers. And so we're going to divide the top by 2, we get 1. And then we divide the bottom by 2. 6 divided by 2 is 3. So the equivalent, the simplest form is 1/3, and that is equivalent to 2/6. So if I were to very carefully kind of draw a picture within this picture, this shows that for every 1, 2, 3 puppies, one of them will have spots. 1, 2, 3 puppies, one will have spots. So this is actually what fractions are, comparing parts to the whole and parts to the set. Ratios are different because a ratio is a type of number that compares two quantities by division, but these quantities are not part of the same whole. They're not part of the same set. So let's imagine that the red counters are puppies. How many puppies would there be in this model? Go ahead and answer that question. Exactly, there are going to be 2 puppies because we have 2 red counters. And if there were, oh, I forgot to put one of these. Okay, if there were, if the yellow were bags of food, then how many bags of food would there be in this model? Go ahead and answer that question. Okay, so that's correct. There are 6 bags of food. So we want to compare puppies to bags of food. So let's say the animal shelter is running a promotion and says for every person who adopts 1 puppy, you get some food. And they look and they notice that there's only 2 puppies left and they have 6 bags of food left. So they want to go ahead and get rid of all of the food. How many bags of food will there be for every puppy that they give away? So in order to do this, we have to come up with the ratio of puppies to food. Okay, so I'm going to go ahead and write that down. So ratio of puppies to food. Now, we're going to use the counters and move them around to figure out how many bags of food each puppy will get. So I'm going to go ahead and take one counter and put it over here, and I'm going to take one counter and put it over here. Okay, so if I give one bag of food to this puppy, one bag of food to this puppy, and I'm going to give an equal amount of food bags to each puppy, when I am done, I'm going to end up comparing two quantities, and it's going to look like this. So I'm going to have puppies on top, and I'm going to have food on the bottom. I could also write it like this: puppies for every bag of food. So let's go ahead and put some numbers with that. So originally there were 2 puppies for the 6 bags of food, but if I look at this picture here, for every 1 puppy, there are 3 bags of food. I could also write it like this: for every 1 puppy, there are 3 bags of food. So ratios can be written either way, and you can see how this can be easily be confused with fractions, but we can also write ratios this way as well. So there are 1 puppy for every 3 bags of food. And you could also write it out as more of a sentence, and you could say 1 puppy for every 3 bags of food. So that's kind of an introduction to what a ratio is. It compares 2 quantities by division, and these quantities are not part of the same whole, they're not part of the same set. We're comparing 2 very different things. Okay, so now you should be on page 269 in your book, and this is a hands-on activity to describe a comparison of 2 different things which we now know is called a ratio. So let's read this word problem together. Max has 3 fiction books and 6 nonfiction books to donate to the community center. He wants to package them so that there are an equal number of fiction books and nonfiction books in each group. He also wants to have as many packages as possible. How many books are going to be in each group? So what do you know? We know he has what? How many fiction books does he have? Go and answer that. Yes, he has 3 fiction books. And what else do we know? How many nonfiction books does he have? Answer that question for me. He has 6 nonfiction books. So what do we need to find? We need to find the ratio. So down here at the bottom, you're going to see that they're representing the fiction books with red counters because there are 3 of them. They're representing the nonfiction books with 6 counters because there are 6 of them, and they're going to be the color yellow. So just like we did with the puppies, we separated the number of fiction books, 1, 2, 3. And then we just gave 1 nonfiction book to each of those until we ran out of nonfiction books to hand out. So the question it's asking you is this: for each group has how many fiction books? Go ahead and answer that question. Okay, very good. Each group actually has 1 fiction book because there's 1 red counter for each one. And so for each red counter, for each fiction book, how many nonfiction books were they able to give away? That's right. They're going to be 2 nonfiction books in each group. And so how many total packages are they able to assemble? So if we were to figure out how many total packages were they able to hand out? Go ahead and answer that question. And the answer is 3. They were able to make 3 packages. So that's how ratios are going to work. Now, the next thing we're going to talk about real quickly is ratio tables, using tables to figure out ratio questions. Okay, for the second activity, we're still talking about books, and you'll notice before we read the word problem that they have created a table. This is called a ratio table. Now, we've made similar tables before to deal with fractions, so you could use the same tool for ratios. In this case, the top part, which would be the numerator if we were talking about fractions, is actually going to be describing the number of fiction books. And the bottom part, which would be the denominator if we were talking about out of a whole in fractions, is actually just going to be representing nonfiction books. So we're comparing the number of fiction books to the number of nonfiction books, which is a ratio because we're comparing two different ideas or things. So Maria is also collecting books. She wants to make packages that have 3 fiction books for every 4 nonfiction books. She already has 9 fiction books. How many nonfiction books will she need? Use a multiplication table to compare the numbers. So what we're actually going to end up doing here is we're generating equivalent ratios. So we're going to go ahead and fill in every single box along the top here. And we're going to do that by skip counting by 3s. Okay, so the top is going to be 3, so the next one will be 6. The next one is going to be what? Answer that for me. That's right, it's going to be 9. And the next one's going to be what? Answer that, please. It's going to be 12. You're right. Now, we're going to continue on with this. We have 15, 18, 21, 24, 27, and we end up with 30. And let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 3 is 30, so we are on track. We're going to do the same thing with the bottom number. So we have 4, then we have 8. So we are actually skip counting by 4s, which is multiplication is repeated addition. So what's the next going to be after 8? What is 8 plus 4? Right? Go ahead and answer that. Very good. That's going to be 12. And what is 12 plus 4? Go ahead and answer that. That answer is 16. Very good. So we're going to continue this. We have 24. After 20, we have 28. We have 32. We have 36. And then we have 40. And 10 times 4 is 40. So we are on the right track. So let's go back to the question. It says she has 9 nonfiction books. Excuse me, 9 fiction books. How many nonfiction books will she need? So if this top is fiction and the bottom is nonfiction, and we know that she has 9, so this is what we know she has right here. So we're going to read across the top to find 9, and then we're going to figure out the corresponding number. So the equivalent ratio to 3 to 4, fiction and nonfiction, the equivalent ratio is going to be 9 to 12. So how many nonfiction books will she need? Well, let's look at the bottom. How many nonfiction books will she need? Go ahead and write that down. Very good. The answer is going to be 12. In this last activity, we have Sanjay has 27 red and blue jerseys. Divide them into 2 groups so that for every 4 red jerseys, there are 5 blue jerseys. So it tells us that the ratio we want to have is 4 red to 5 blue. So the first thing we're going to do is go ahead and fill in by skip counting all the way across the top by 4. So that's going to be 12, 16, 20, okay, that's supposed to be 20, 24, 28, 32, 36, and 40. Okay, now we're going to skip count across the bottom by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. All right, my pen was having some issues, but we got there. So, but we have to go back to the problem here because we know the total number of jerseys is 27 jerseys. And so we put them all into groups by skip counting across this table. So we have to figure out at what point do we have 27 jerseys. So we have to actually put these two together. So if we say 4 plus 5, what's that number going to be? Write that down for me. That's going to be 9. So if we have 4 red jerseys and 5 blue jerseys, we have 9 total jerseys. So let's see what this next one's going to be. If we have 8 plus 10, what total number is that going to be? That is going to be 18. Right, you're exactly right. So if we're going to do the same thing going across again. If we have 12 red jerseys and 15 blue jerseys, what is 12 plus 15? Write that down. All right, that is going to be 27. So this is the ratio that we're looking for. So now we can answer the question, how many red jerseys are there? Go ahead and write that down. 12. And how many, that's supposed to be 12. How many blue jerseys are there? Write that down. 15. Very good. So the one important thing I really want you to learn from this video is that fractions and ratios look very similar, but they are different. Fractions compare parts of a whole of the same kind of thing, whereas ratios compare the relationship between two separate things. So it's a comparison of two quantities by division. All right. So go ahead and answer that question for me. What do you think the most important thing to remember in this video is?